Welcome to Secret Machinery channel. Don't forget to subscribe, like, share and leave a comment if you find it interesting. In today's video I will show you how to build the biggest bridges in the world. And especially how the giant bridge assembly construction machines work. The first thing I want to introduce to you is the SLJ 900, biggest bridge girder erection machine. This machine weighs 580 tons, 91.8 meters long, 7.4 meters in width, and 9 meters in height. She is able to lift 900 tons of stuff. SLJ 900 has main support leg adopts the joint-dominated triangular structure. The supporting will train JP3 mechanism is used on the main support leg. Without any anchor measures, the main support leg is designed to realize the structure self, JP stabilization and can resist overturning moment which bridge erecting machine over the span to the next pier. With the constant drive mode on the main support leg, the bridge erecting machine realizes the synchronization control mode of different driving methods and improves the safety and reliability in operation. Through alternating functional transformation technique of the main support leg and auxiliary support leg, the bridge erecting machine can over the span to the next pier without the need of the guide beam. The operational process is simplified and the bridge erecting machine can erect box girder at the tunnel entrance and erect box girder inside the tunnel. You may not know this is a work done by Beijing Huaojoint Machinery Company. Huaojoint Holdings Limited is a leading innovative infrastructure solutions provider of customized heavy-duty lifting and carrying machinery used in large-scale projects. It was founded in 1996 by experienced engineers predominantly in the railway industry. But it has evolved into a global leader in the bridge and highway markets, as well. Today affiliate companies, agents and locations of Huaojoint Holdings Limited are spread out all across the globe. From 1996 to 1997, Mr. Yabin Liu and Mr. Fu Zhang, who had worked as researcher and engineer in railway field for more than 15 years, founded Beijing Huaojoint. The beginning company represented as sole agent in China for European companies, including Paolo de Nicola of Italy, MKG of Germany, Wertes of Switzerland, etc. Acted as a pioneer, Huaojoint developed and promoted prefabricated method for railway bridge erection in China. And then impelled China Ministry of Railway to accept FSM full span method and applied it in the construction of the first HSR line Qinghuangdao Shenyang in China. From 1999 to 2002, Huaojoint was awarded the contract for supplying 550-ton special launching carrier, which was the first machine in China for erection of full-span prefabricated box beam on project of the first high-speed railway. The company developed and introduced method span by span for segmental viaduct and supplied the first set of launching gantry span by span 1600T in China. At the same year, the company provided 3 large-scale tonnage carriers for the project of Shanghai Maglev. From 2002 to 2004, Huaojoint supplied consulting service on FSM for project of Hangzhou Bay Bridge construction and issued new erecting solution on passing through tunnel for the construction of HSR bridge in mountain area. From 2005 to now, the contract for supplying the launching gantry in 900 tons capacity and the special carrier in 900 tons capacity for HSR, which were of the first sets in China, was awarded by Huaojoint. The company founded its factory in Tongzhou, Beijing, and manufactured the first set of special launching carrier for passing through tunnels, capacity 900 tons in the world. It is exciting this period for exporting for sets of special launching carrier in capacity 990T to Korea for Hunan High-Speed Railway and 2 sets of lifter to USA. Next we come to the replacement of Dickinson's Creek Bridge. Dickinson's Creek Bridge was demolished and the road closed for 3 months from the 17th of February 2015 as work begins to build a new bridge. Greater Taree City Council recently awarded the $1,821,500 contract to demolish the existing bridge, build a new bridge and the relevant approach roadworks to Delaney Civil Party Limited. The 33-meter former timber bridge carries Moto Road over Dickinson's Creek and is about 12 kilometers north of Taree. It was built around 1950 and is described in a report to Council as being in a poor condition with a current posted weight limit of 5 tons. Work has begun on the 17th of February 2015 with Delaney Civil Party Limited with a 19-week construction period. Council was preparing a communication plan to ensure local residents are informed of the impact of the works on use of Moto Road. According to a report to Council, the on-alignment replacement and method of construction for a single-span bridge requires close of the bridge for about 3 months. Council has identified that during the 3-month closure, the detour will be via Lansdowne and Cundall roads, which will add about 4 kilometres to a trip from Taree to the location north of the bridge. The tender allocation for the Dickinson's Creek Bridge works is part of the Greater Taree Roads and Bridges package. Council has already spent $1.1 million on preliminary works for a number of infrastructure projects in the Manning Valley, including the design of plans to replace Dickinson's Bridge, Dyas Crossing Bridge at Dyas Crossing, as well as reconstruction works on Manning Point Road from Old Bar Road to Bonnock Bridge and sections of Gloucester Road. Federal government funding for the replacement of Dickinson's Creek Bridge and Dyas Crossing Bridge came to Council's coffers following the controversial redirection of funding from the Northern Gateway project. The issue polarized the community last year after the federal government reneged on funding the Greater Taree Roads and Bridges package, which according to Council, was a fully funded allocation in the 2011 to 2012 budget. Council secured the funding allocation in 2011 via the federal government's Community Infrastructure Grant Program. It was a 2-stage funding program with $1.1 million allocated in Stage 1 and $11.4 million in Stage 2. However, in December 2013, federal member for Lyne David Gillespie announced that federal funding had been withdrawn. Fast forward to July last year, and Deputy Prime Minister and Minister for Infrastructure and Regional Development Warren Truss announced that the federal government would provide $10 million to assist Council to deliver the Greater Taree Roads and Bridges package. Mr. Truss said funding for the project had been transferred from the proposed Taree Northern Gateway project, which had not received the anticipated matching contributions. Finally, I invite you to watch Bridge Construction, Incremental Launching, 3D Animation. Incremental launching of bridges can save time, money, space and disruption while easing access and delivering a high-quality finish. The incremental launching method is particularly suited to the construction of continuous post-tensioned multispan bridges. It involves casting 15-30 m long sections of the bridge superstructure in a stationary formwork behind an abutment and pushing a completed section forward with jacks or friction launching system along the bridge axis. Alternatively, the launching can be done by means of hydraulic pulling jacks using strand or bar temporary tendons. A steel nose is installed on concrete viaducts or a temporary tower with stays on metallic decks. The sections are cast contiguously and then stressed together. The superstructure is launched over temporary sliding bearings on the piers to keep the bending moment low in the superstructure during construction. A launching nose is attached to the front of the bridge deck. The main advantages for using this construction methodology, rather than other traditional methods, are minimal disturbance to environmentally sensitive areas, smaller assembly zone required, greater safety during construction, which is mainly carried out at ground level, economy of transportation and general reduction in construction elements, higher quality finish and performance derived from easier working conditions and repeatability of tasks, ease of access to restricted or limited sites such as over rivers, deep valleys, road or train lines, in poor soil conditions or environmentally protected areas. Although its significant advantages make using this technique a highly attractive option, certain aspects require a high level of expertise, both in terms of people and equipment, offered by members of the BBR network. They have much experience, acquired over many years, in the techniques of incremental launching and a track record for successful delivery of launched structures all over the world.